Hey everyone, Alex from Openfort here. In a previous video I introduced myself, so who still didn't watch the video. So I'm a Solidity senior engineer in the company. In the previous video we was talking about the new EIP-7702 that's gonna be included in the next upgrade Spectra on Ethereum this week. So in this video I want to introduce you Openfort Delegator contract for the EIP-7702. We will talk about the design of the contract, implementation of session keys, WebAuthn and P-256. Also, we will talk about integration of the 4337 infrastructure, protection and security, and I will drop some use cases. So let's start. Before we are starting, so I just want to drop the link for our YouTube that you can see the previous video and understand exactly what EIP-7702 doing. So let's move and make an overview or our design delegator contract. So basically we were thinking about create a modular smart contract that will include a different type of features. So basically we have the basic delegator account that will include access control, initialization, verification of signatures, and two type of execution. One is batch and the other one is a single execution. Then we add session key that will be registered with WebAuthn and validation with P-256. And we add another feature in next module that we are at infrastructure of 4337. So actually it's going to be compatible with all infrastructure of account abstraction and full smart account. So it will include all features that I mentioned before, include guardians and option to make your account recoverable. So basically this is the design we thought about. It could be modular and users can attach one of the options to their EOAs and upgrade to be a smart account. So what is session key? The full definition you can search in the Google and find exactly what doesn't mean session key. For our implementation, we are decided to do a two type of session keys. So basically for us, a session key, it's another external key that can execute or do any action or engagement with the smart contract. Means that we can execute transactions, send tokens, or do any activity on our smart wallet. We did implementation for two type of keys. One of them EOA. It's just a regular account of the Ethereum that working with specific curve, and we can do recovery of the address of the signer with ECDSA and the precompile EC recover. And other type of key, it's WebAuthn that using with a different curve standard, and it's also recovering a signer with P-256 verifier and using with the precompile mod exp. So about EOA, I'm not gonna explain again. You can see our previous video. I'm explaining about this type of account. So let's go and understand what is this exactly WebAuthn. So WebAuthn, it's a web authenticator based browser standard, and it's give to users to sign a message or authentication using this biometric or passkey or hardware keys like YubiKey. And P-256 is just elliptical curve standard. It means that it's can be used in the public key cryptography, and WebAuthn often use to generate public-private key with this curve. You can find more information about this standard in Google and understand exactly what it's doing. Also, I will leave some links to read technical documentation about web authentication and how exactly we are creating credentials and how we are doing public keys and other technical information that you can find in these websites. So if we know for the account of EOA, we have a private key and we have the address. So how exactly looks WebAuthn? So we have also public key. We have 2 points of X and Y. And then we have different metadatas that we are creating when we are registering a credential with WebAuthn. And I will show you in a short demo that I prepare how exactly we are getting with biometric registration the credential and the other metadata to verify our signature with P-256. How exactly everything works together. So we can see this example that I prepare. Basically, Alice, she's the owner of the account. She has the private key for the EOA. EOA was attached the designator code of Openfort with full modules that I showed in the beginning of the video. She generating the WebAuthn signature with her personal device, and this is how the struct of the data looks. So we are taking the public key and we are registering to our account. So basically we are registering the public key as a session key. Then if we want to execute any transaction or do any engagement with our smart contract with a session key, so basically we have to pack to the signature all this information that our contract have to validate. So we are sending this user operation struct to bundler or relayer, and then we're this all pack user operation going to EntryPoint, and then it's engaging with our smart contract, and basically it's doing validation of the session key, verifying it's the signature correct, and recovering the public key. And see exactly the signer, it was Alice with her passkey that saved in her device, and then it's executing transaction on behalf of her account. So it means that she don't need anymore to sign call data or of the transaction with her private key. Right now she can use with the passkey and execute any type of transaction with her account. In the Openfort implementation, we decided to give possibility to register 2 type of session keys. One of them is master key and limited session key. Basically, master key can be WebAuthn or other EOA that will execute on behalf of the owner, acting as a primary or secondary owner and has not any limits. And limited session key also could be WebAuthn or other EOA, acting as a limited key with strict policy and has limitation. Which information we have to provide to register a session key? So it's public key of the session key. If the session key is active, valid until means that session key have expiration. Valid after, limits, a limit of the action this session key can do with the smart account. Master session key if we want to register this key as a master key. Whitelisting means that we can register smart contracts that it will be in whitelist that session key can engage, spend token info, allowed selectors that will be allowed to engage with the smart contract addresses that we are registered in the whitelist, Ethereum limits, that amount of the ETH that this session key can send, and of course who registered this session key. In the struct of the spent token information, we are registering the token, that the address of the token that this session key can engage, and limit amount of the tokens that this session key can spend. Which type of protection and security we are implemented into the Openfort account? So basically it's access control. It means that owner can execute any type of transaction or a session key that we are registered, or we can execute transaction through the EntryPoint. Initialization, so after we are attached the code of the delegator to our EOA and upgrade it to 7702, we must have to initialize our account. Then we have implementation of the verification of the signature, include EIP-7712. Also we allocated unique storage, so to prevent storage collision. Also we are do clear storage before initialization. It means that if the implementation had previous storage, so it's cleaning the slots that we are allocating to prevent also storage collision. We have a session keys implementation, also is valid signature of standard ERC-4337 and reentrancy guard. So let's see how initialize function exactly working. We have modifier of initializer, that it means that this function could be executed only once to prevent multiple initialization. We have modifier that checking who exactly executing this transaction, if it's the owner of the account or it's coming through the entry point. Also we are clearing the slot storage, that exactly we are did unique allocation of the storage. We do a different validation. We are checking the signature if the signer is exactly the owner, and then we are set up the owner, increasing the nonce. Let's see what exactly means storage allocation. In our implementation, we are allocating unique storage layout, means the storage will start from unique slot. It means to be prevent a storage collision or overwriting of previous storage. For example, if the EOA was attached with a delegator, so we want 100% be sure that the storage will start from unique slot and will not overwriting or will do any collision. Also, during the initialization, we are calling to internal function clear storage. So here we want to be sure that the slots that we are allocating and want to initialize, we are deleting all previous information. For the session key, we have also protection. Session key of type WebAuthn. We have a mapping of use challenges. So basically when we are signing any type of information with our credential of WebAuthn, we also signing a challenge. This challenge we have to provide for the validation. So this challenge can use as a nonce and also prevent a replay attacks. And we have a function to validate session key. Is validating if the session key is master key or limited key, and if it's limited key, it will check all policy that the owner registered for this session key. Let's wrap up all information we have. So in the implementation of Openfort, we have a modular smart accounts. So basically user can attach any type of modules to their EOAs and upgrade to acting as a smart account. We talked about a type of session key that Openfort have in implementation. Also, we was talking about what is this WebAuthn. We talked about exactly how the registration of the session key happen, include the ERC-4337 infrastructure, and exactly how we are executing with the session key. Also, I explained about type of session keys that we can register in our implementation. Also, we did overview of the protection and security that we are implemented in our smart contract delegator. In the next video, I'm gonna show you a live demo of our implementation and how it's exactly working with the session key, a full flow from the registration and execution with master key and also limited session key. So thank you very much. Here it was Alex. So see you in the next video. Bye bye.